Okay, this is a question about stationary points, so I'm going to be using that dy by dx equals 0 at a stationary point. Okay, but I'm also going to later on have to determine their nature, so I'm going to have to find out what kind of stationary points they are. It might be a maximum point or a minimum point or one that isn't either. So we'll start anyway just by finding what the stationary points are. So dy by dx equals 0. Well, here's why. I need to find dy by dx. So dy by dx, differentiate what I see. X to the power 4 differentiates to 4x cubed. And 2x cubed differentiates to plus 6x squared. And at the stationary point, that's going to equal 0. So I take out I've got a load of powers of x, so I take out the smallest power of x as a common factor. X squared times brackets 4x plus 1, no, plus 6 has to equal 0. So either x squared equals 0, which does lead to a solution, or 4x plus 6 equals 0. Okay, so x squared equals 0 leads to x equals 0, so that's a possibility. And 4x equals minus 6 leads to x equals minus 3 over 2. I divide by the 4. So I've got two x coordinates. Of course I need the y coordinates. So x equals 0 implies that y equals, well, if you sub 0 in for x, these will both equal 0, so y will equal 0. So one of the stationary points is at the origin. And the other stationary point, when x is minus 3 over 2, y is, so y is minus 3 over 2 to the power of 4 plus 2 times minus 3 over 2 cubed, which is a calculator job probably. It's minus 27 over 16, so the other stationary point is minus 3 over 2 minus 27 over 16. Okay, but now I've got to work out what's going on at each stationary point. So one thing that can help is the second derivative. So d2y by dx squared tells me whether it's convex or concave, whether it's bending up or bending it down, or whether it's feeling positive in a smile, or whether it's feeling negative in an unsmile. So d2y by dx squared, well, I need to find dy by dx. Well, I've properly labelled it up here. Okay, so differentiate that again. Okay, and I'm going to get 12x squared, and the other one is going to be plus 12x. Okay, so I'm going to be looking at that. Now let's do the second one first. When I take x to be minus 3 over 2, okay, so d2y by dx squared when x is minus 3 over 2, well, I just have to sub minus 3 over 2 in. 12 minus 3 over 2 squared plus 12 times minus 3 over 2, and I get an answer which turns out to be 9, and that is positive. And if I'm feeling positive, it looks like that. So therefore this is a minimum point, and this was the minus 3 over 2 minus 27 over 16. So give answers at the end. Minus 3 minus 3 over 2 minus 27 over 16 is a minimum. Okay, minimum. Okay, but when I do d2y by dx squared evaluated at x equals 0, then when I put 0 into this expression, I just get 0. Okay, so this is an inconclusive result. It's not positive or negative, so I can't resolve whether the origin is a maximum, a minimum, or something else. Okay, but one thing that could help is if I've got d2y by dx squared being 0 and d3y by dx squared isn't 0, then I do know that it's a point of inflection. So let's try that one. So we'll try d3y by dx cubed. So I take my d2y by dx squared. Notice this expression for dy by dx has got a common factor of 2. Okay, I'm not allowed to divide by 2 and still claim it's dy by dx. I have to keep the common factor in. This has got an even more blatant common factor of 12. I'm not allowed to divide it by 12, otherwise it wouldn't be d2y by dx squared anymore. So you can't get rid of these factors. I'm going to differentiate what I see for d2y by dx squared to get d3y by dx cubed. So that is 12x squared differentiates to 24x, and of course 12x differentiates to plus 12. And I was interested in this when x equals 0. That was my problem point. And this equals, when I put x equals 0, this equals 12 at x equals 0, which is not equal to 0. 12 is not 0, so I've got a 0 value for the second derivative, but the third derivative is non-zero, so that confirms that this is a point of inflection. So therefore, 0, 0 is a point of inflection. And I've run out of room here, so I have set this out really badly. But I can double underline that, and I can double underline that, and I'll just about get away with that presentation, I hope. Okay, so I've got the two stationary points, I've got their coordinates, and I've got what kind they are.